Okay, student. Now previously we will find a maximum amplitude of the carrier after AM modulation, V maximum, which is equal to AC into 1 plus mu, and V minimum, which is equal to AC into 1 minus mu. Now this is maximum amplitude of the carrier after AM modulation. This is minimum amplitude of the carrier after AM modulation. Now this is nothing but, so can I write like this? V maximum, which is equal to AC plus AC into mu, V minimum, which is equal to AC minus AC into mu. So this V maximum, if I add these two, V maximum plus V minimum, which is equal to plus AC minus AC cancel, this is 2AC. So AC equal to V maximum plus V minimum by 2. So this is AC, V maximum plus V minimum by 2. So if V maximum and V minimum is given, if he is asking to find AC, then this is the way you can calculate the AC value. Okay, and the modulation index is already calculated, V maximum minus V minimum by V maximum plus V minimum. Okay, now come to this equation. Now this is the AM wave in single tone. Now this is carrier, this is FC plus FM upper side band, FC minus FM lower side band. Okay, so the AM wave consisting of carrier, upper side band, lower side band. Now we just know we are calculating the bandwidth required to transmit AM signal, right? Now similarly, now we want to calculate what is the total power required to transmit the AM signal, because power and bandwidth are the communication resources. Okay, for any modulation technique, for any communication system, these two parameters which are important, one is bandwidth and one is power. Now the bandwidth analysis part which we already completed, now we'll see the power analysis. Okay, now what is the total power required to transmit an AM signal? Now see here, the total power required to transmit an AM signal is, the total power required to transmit an AM signal is the power taken by the carrier component, power taken by the upper side band plus power taken by the lower side band. Okay, the power taken by the carrier component, power taken by the upper side band and power taken by the lower side band. Now all these are the sinusoidal modulation technique. Am I not? Message signal is carrier, analog modulated signal is analog signal, message signal is analog signal, and message signal is also analog signal. Therefore all these are the sinusoidal signals. Therefore now while we are calculating the power, now we want to calculate the RMS values. Vrms square by R is power, or Irms square into R, or Irms square into R is power. Now what is the RMS value? The RMS value, which is nothing but peak amplitude divided by root 2. The peak amplitude divided by root 2 is nothing but the RMS value. So the RMS value is nothing but peak amplitude divided by root 2. Peak amplitude divided by root 2 is RMS value. Vrms square by R is power, right? Now similarly, what is the carrier peak amplitude? AC divided by root 2 is RMS value. Vrms square by R is power. Now what is upper side band peak amplitude? Upper side band power, lower side band power is same, because upper side band peak amplitude, lower side band peak amplitude is same. Square by R. Now plus lower side band AC mu by 2 divided by root 2 is RMS value. Vrms square by R is power. Now this is the total power required to transmit an AM signal. So now the total power required to transmit an AM signal, which is equal to AC square by 2R plus AC square mu square by 8R plus AC square mu square by 8R. So the total power which is equal to AC square by 2R plus AC square mu square by 8R plus AC square by mu square by 8R is 4R. So what is the total power? The total power which is equal to AC square by 2R, if you take it as a common, 1 plus mu square by 2. Now what is AC square by mu R? Now we will take individual powers. So the carrier power is AC square by 2R is a carrier power. So can I write what is the total power? The total power required to transmit an AM signal is PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. This is the total power required to transmit an AM signal. Okay. Now, which is a function of modulation index mu? This is the total power required to transmit an AM signal. Now, which is carrier power plus upper sideband power plus lower sideband power, which means that the total power required to transmit an AM signal is carrier power plus sideband power. Now I am asking what is the carrier power? This is the carrier power. Now what is the total sideband power? The total sideband power, which is nothing but upper sideband power plus lower sideband power. The total sideband power, which is equal to upper sideband power plus lower sideband power. Now what is the upper sideband power? The upper sideband power, which is nothing but AC square mu square by 8R plus lower sideband power AC square mu square by 8R. This is the upper sideband power and lower sideband power is the total sideband power. Therefore, which is equal to AC square mu square by 8R plus 8R 4R, which is equal to AC square by 2R into mu square by 2. AC square by 2R is what? Carrier power. So the total sideband power, which is equal to PC into mu square by 2. This is the total sideband power. This is the total power and this is the sideband power. Okay. Now, where is the information? The information is nothing but message signal amplitude. Before modulation, the information is there in the message signal amplitude. My question is, where is information after modulation? Now, after modulation means carrier amplitudes are contains the message signal information. Is it right or not? The carrier amplitude is changing in accordance with the message signal amplitude. So, after modulation, the information is available in the sidebands. When we come to the time domain, no confusion. Amplitude of the carrier is varied in accordance with the amplitude of the message signal. But when you come to the frequency domain, sir, then frequency domain spectrum consisting of 3 components: carrier, upper sideband, lower sideband. So the information components are sidebands. Sidebands are the information resource. Sideband components are the information storage contents. Sidebands are the information storage resource. After modulation, okay. Now, before modulation, the message signal amplitude is available, carrier signal amplitudes are available, but after modulation, the sidebands or components are the information storage resources. So, now the question here is, now this is the sideband power, this is the total power, okay. Now, this is the power calculation, power required to transmit the AM signal. See, the bandwidth of the modulated signal should be as low as possible, okay. The bandwidth of the modulated signal or any signal should be as low as possible. The condition is we can accommodate more number of signals, means multiplexing is good when the modulated signal bandwidth is less, okay. Now, power required to transmit the signal is also as minimum as possible Now because the power required to transmit the signal is less, so it is an advantage. Okay, this is the power calculations. Note down first. Okay, see here. Now this is the sideband power. The sideband power, which is nothing but Pc into mu. What is mu? Ka square am square by 2. So here the sideband contains information. Am is amplitude of the message signal. So this is important. The sideband contains the information. Okay, rather than the carrier. What is carrier? Carrier is nothing. AC square by 2r. There is no information here. This is not important. What is important? The sidebands are information. The sideband contains the information. The sidebands are the information storage elements, storage components. Clear or not? Okay. Now see here. Now first we will finish what is the importance of this power. Now see here. Now this is the total power. The total power is nothing but carrier power plus sideband power. Now which is nothing but the total power, which is equal to Pc into 1 plus mu square by 2. Pc into 1 plus mu square by 2. Now when modulation index equal to 0, when modulation index equal to 0, the total power, which is equal to carrier power plus what is mu? Mu equal to 0. Pc into 0 square by 2. So which means that the total power, which is equal to Pc plus 0, means what happened now? Now which is nothing but Pt, which is equal to Pc plus Psb, very sideband. Now the sidebands are 0. When modulation index equal to 0, when modulation index equal to 0, there is no sidebands. There is no sidebands. When modulation index equal to 0, there is no sidebands. If there is no sidebands, which means no modulation. No modulation. There is no modulation if there is no sideband. If there is no sideband, when the modulation index equal to 0. That is the reason why, therefore modulation index must be greater than, modulation index must be greater than 0. If modulation index equal to 0, which means there is no sidebands. If there is no sidebands, there is no modulation technique, nothing. That is the reason why mu should be greater than 0. What is the reason behind mu must be greater than 0? Why mu is not equal to 0? Why mu is equal to 0? What happened? If mu equal to 0, no sidebands, no modulation, nothing. Understand or not? Note down this. This is a very, very important point. And one more thing also. Okay. And one more thing. What is V maximum? The maximum amplitude of the carrier after modulation is AC into 1 plus mu, which is equal to AC into 1 plus mu, which is equal to AC. When modulation index equal to 0. V minimum. What is V minimum? V minimum equal to AC into 1 minus mu, which is equal to AC into 1 minus mu is 0, which is equal to AC. This is V maximum. This is V minimum. Maximum amplitude of the carrier after a modulation. Minimum amplitude of the carrier after a modulation. Amplitude of the carrier before modulation is AC, AC, AC. Everywhere it is AC. Maximum is AC. Minimum is AC, which is nothing but the carrier before modulation, which means that then there is no modulation. Everything will be AC. When mu equal to 0. When mu equal to 0, carrier after modulation will be same as that of carrier signal after modulation will be same as that of carrier signal before modulation. Carrier signal after modulation which is equal to the carrier signal before modulation when modulation index equal to 0. When modulation index equal to 0. Therefore, before modulation, after modulation, carrier amplitude will be same. There is no modulation. Any one of the carrier characteristic parameter is changing, then only the modulation is done. Now, this is the reason why mu must be greater than 0. Why mu is not equal to 0? What happen if mu equal to 0? What happen if mu equal to 0? Then this is the story behind the modulation index equal to 0. No doubt. Okay. So now we'll see the power efficiency. Power efficiency or modulation efficiency. Power efficiency or modulation efficiency. Now, what is efficiency? Output by input. Now, out of total power, how much power is used by the information components? The information components are sidebands. The out of total power, how much power is used by the sidebands is nothing but the power efficiency or modulation efficiency. So, what is the total power? The total power which is nothing but Pc into 1 plus mu square by 2 sideband power which is equal to Pc into mu square by 2. Pc cancel which is equal to mu square by 2 plus mu square which is the function of modulation index. But you know that now what is the maximum modulation efficiency? The maximum efficiency of an AM wave, which means that mu is 1, the maximum efficiency which is equal to 1 square by 2 plus 1 square. So which is nothing but 1 by 2 plus 1 which is equal to 1 by 3 which is 0.333 which is equal to 33.33%. This is the maximum efficiency of an AM wave. The maximum efficiency of AM wave which is 33.33% which is very less. The maximum efficiency of AM wave is 33.33% which is very less because now you see here what is the reason behind that, because the major information is available in the sidebands. There is no information in the carrier. The information is available in only sidebands. Now therefore now you see here what is the total power? The total power which is equal to Pc into 1 plus mu square by 2, but now here it is Pc which is equal to 1 plus mu is 1 by 2 which is equal to Pt which is equal to Pc into 2 plus 1, 3 by 2. Therefore, what is the carrier power? The carrier power which is equal to 2/3 of the total power. The carrier power which is 2/3 of the total power. Carrier will take 2/3 of the total power. Now, what about the remaining power? Now, here efficiency which is equal to sideband power by total power which is equal to 1 by 3. Therefore, sideband power which is equal to 1/3 of the total power. Sideband power which is equal to 1/3 of the total power. Sideband power which is equal to 1/3 of the total power. The sidebands which are the information components will take only 1/3 low power. The carrier there is no information in the carrier, but it will take more power. The sidebands will take less power. The sidebands will take less power compared with carrier. The sidebands will take less power compared with carrier. Therefore, power efficiency decreases. The power efficiency decreases because when the sideband power is decreases and automatically the sideband power is decreases, then the sideband power, if the sideband power is decreases, then the power efficiency is also decreases. This is the reason why the maximum efficiency of AM wave, which is 33.33%, which is very less. The reason behind that, the sidebands will take less power compared with carrier. Carrier will take more power compared with sidebands. When the sideband power is decreases, efficiency is decreases. No. Now, what is the total power? The total power required to transmit is PC into 1 plus mu square by 2. Okay. So, now this is the power I can write in terms of current. This is IT square into R, which is equal to IC square into R into 1 plus mu square by 2. So, which is nothing but, now this is IT, which is equal to IC into square root of 1 plus mu square by 2. Now this is IT, which is nothing but transmitting antenna current. Transmitting antenna current or total current after modulation. Okay. Now this is IC is nothing but antenna current before modulation. This is the transmitting antenna current or total current after modulation. R is antenna resistance. If antenna resistance is not given, if R equal to 1 ohm, normalized value and all are, therefore all are normalized powers. If R equal to 1 ohm normalized value, then you can take all our normalized powers. Okay. Note down. Now this is the classroom workbook question number 1. Remember the classroom workbook question number 1. Now the amplitude of the AM signal. Now first you will read the question once and twice and you can easily understand. The amplitude of the AM signal. AM signal means after modulation or before modulation? After modulation. The amplitude of the AM signal varies from 2 volts to 10 volts. Varies from 2 volts to 10 volts. Means what? Amplitude modulation means modulation is done, completed, carrier is after modulation. So amplitude of the signal is varies from 2 volts to 10 volts, which means that this is V minimum and this is V maximum. This is V minimum and this is V maximum. 2 volts to 10 volts. Now determine all powers of AM. What is the question? Determine all powers of AM. So all powers. Let us check with first carrier power. What is the carrier power? AC square by 2R. But here AC is not given. But what is given is given only V maximum and V minimum. Now first we will find V maximum with V minimum. How to find AC? What is AC? Now AC, which is nothing, you know the formula AC, which is nothing but V maximum plus V minimum by 2. So which is nothing but 2 plus 10, 12 by 2, which is equal to 6 volts is the carrier amplitude. Next, carrier power. What is the carrier power? The carrier power PC, which is equal to AC square by 2R, which is equal to 6 into 6 by 2. R is not given, 1 ohm, which is equal to 18 watts. This is the carrier power. Now, what is the total power? The total power, which is equal to PC into 1 plus mu square by 2, which is equal to PC. PC is 18 into 1 plus. But a modulation index is given? No, there is no modulation index. Then how to get the modulation index? But now see here, what is a modulation index? A modulation index is also, there is a problem. V maximum minus V minimum by V maximum plus V minimum. V maximum plus V minimum, which is equal to 10 minus 2 by 10 plus 2, 8 by 12, 2 by 3, 0.6 is the modulation index. Now, the total power, which is equal to PC into 1 plus mu square by 2, which is equal to, what is PC? PC, which is equal to 18 into 1 plus 0.6 whole square by 2. Now, what is the sideband power? What he is asking, what is the sideband power? The sideband power, which is equal to PC into mu square by 2. PC is available. What is PC? 18 into mu 0.6 whole square by 2. This is the sideband power. And what else he is asking? Now this is all powers: carrier power, total power, sideband power. And he may ask also efficiency. What is efficiency? Efficiency equal to mu square by 2 plus mu square. If he is asking, you can find this one also, because mu is also available, 0.6 whole square by 2 plus 0.6 whole square. Everything is expressed in terms of percentage. All powers. This is question number 1 in our classroom workbook. Okay, no doubt. Classroom workbook, question number 2. An AM signal represented in time domain as S of t. An AM signal represented in time domain as 4 cos 1800 pi t plus 10 cos 2000 pi t plus 4 cos 2200 pi t. Now this is an AM signal represented in which is represented in time domain. But generally the students' minds are like this. Now there are 3 components. Therefore, this is carrier, this is upper sideband, this is lower sideband. Then you generally go like this: carrier, upper sideband, lower sideband. So if you go like this: carrier, upper sideband, lower sideband, then the carrier amplitude, most of the students are taking that the carrier amplitude AC equal to 4. Carrier power, which is nothing but AC square by 2R, which is equal to 4 into 4 by 2 into R is 1, like this. Therefore, if you go like this, definitely you can get the answer, which is 100% a wrong answer. Okay. If there are 3 components, don't by heart like this: carrier, upper sideband, lower sideband. This is the wrong approach. Why this is wrong? Why this is wrong? Which means that here you just see here. Now this amplitude will be same. In AM, there are 2 component amplitudes are same. Those 2 components are called as sidebands. This is the upper sideband or this is the lower sideband. But which is upper sideband, which is lower sideband, that you decided. But those 2 component amplitudes are same. Those comes under upper sideband. So which one is upper sideband, which one is lower sideband? What is the frequency here? 2200. Wrong. Frequency is scaling of 2 pi f into t. Now here 1100 Here 900, less frequency lower side band, more frequency upper side band. Then what about the remaining thing? The remaining thing is this is the carrier component. If you assign like this, you can easily get the answer. Now here is the equation you see. Now this is nothing but you can represent it like this. S of t, which is equal to 10 cos 2 pi into 1000 into t plus 4 cos 2 pi into 1100 into t plus 4 cos 2 pi into 900 into t. Carrier upper side band, lower side band. Therefore, what is the bandwidth? Now the bandwidth is the first parameter, upper side band minus lower side band, completed. Upper side band is 1100 minus lower side band is 900, which is equal to 200 hertz is the bandwidth. Now carrier power, the carrier power which is equal to AC square by 2R, which is equal to 10 into 10 by 2, R is 1 ohm, which is equal to 50 watts. Now the total power which is equal to PC into 1 plus mu square by 2, which is nothing but, what is PC? The PC which is nothing but 50 into 1 plus mu. Where is mu? Modulation index is available. So you can compare here. AC mu by 2, which is equal to 4. AC mu by 2, which is equal to 4. Now here AC, compare AC equal to 10 volts. Therefore, mu which is equal to 4 into 2 by AC, which is equal to 8 by AC, which is 8 by AC is 10, which is equal to 0.8. Now this is the modulation index. Once the modulation index is available, you can calculate all the powers. 1 plus 0.8 whole square by 2. Now what is the sideband power? The sideband power which is equal to PC into mu square by 2, which is equal to PC is 50 into mu is 0.8 whole square by 2. Now what is a modulation efficiency? Is mu square by 2 plus mu square. What is mu? Mu is available 0.8 whole square by 2 plus 0.8 whole square. Now all powers, sideband power, total power, carrier power, modulation efficiency, bandwidth, everything is available. You can easily calculate. No doubt. Now this question number 3. The question number 3 is an AM signal represented in time domain as S of t, which is equal to 10 plus 4 cos 2 pi into 10 power 3 into t, and AM signal represented in time domain into cos 2 pi 10 power 6 into t. Now this is the AM signal represented in time domain. Then determine all parameters of AM. All parameters is nothing but power, bandwidth and all these things. Now see here. Now this is an AM wave or not? Now first you converted this into a standard AM wave. Now here if I take 10 as a common, 1 plus 4 by 10, 0.4 into cos 2 pi into 10 power 3 into t into cos 2 pi into 10 power 6 into t. Now this is nothing but S of t, which is equal to AC into 1 plus mu cos 2 pi Fm into t into cos 2 pi Fct. Then if you compare these two, now AC which is equal to 10 volts, modulation index which is equal to 0.4, FM frequency of the message signal which is equal to 1 kHz. Whenever the frequency of the message signal is available, you can easily calculate the bandwidth. What is the bandwidth? The bandwidth which is equal to 2 FM which is equal to 2 into 1 kHz which is equal to 2 kHz. Right? Now carrier power AC square by 2R. Now this is 50 watts. PC into 1 plus mu. What is mu? Modulation index mu here is 0.4. Now PC into mu square. What is mu? Mu which is nothing but 0.4 square. Now modulation index is 0.4 plus 2 plus 0.4 whole square. Now this is the all powers and all parameters of an AM transmitter radiates 8 amperes when the carrier is unmodulated. See here what he is asking. An AM transmitter radiating 8 amps means current. An AM transmitter radiates 8 amperes when the carrier is unmodulated. Unmodulated means before modulation 8 amps. And it increases to 9 amperes when the carrier is modulated. When it increases to 9 amperes. Now my question is, before modulation is 8 amperes, why after modulation it is increases? Why not it is decreases? Now can you think? Before modulation is 8 amperes, after modulation why it is increasing? Why not it is decreasing? Because you know one thing, now before modulation only carrier is available. But after modulation what are additional component? Sidebands. When sidebands are adding, so the total power is definitely increases before the modulation power. So then what he is asking? He is asking modulation efficiency. So you know that what is IT square? IT square which is equal to IC square into 1 plus mu square by 2. Now which is equal to 9 square which is equal to 8 square into 1 plus mu square by 2. Now which is nothing but, now from here we can find the modulation index. Now what is the power by efficiency? Mu square by 2 plus mu square. Everything is available. Now question number 5. What is question number 5 in our classroom workbook? Now question number 5 is an AM transmitter radiates 50 watts. An AM transmitter radiates 50 watts. Most of the students are confusing. Now this 50 watts is taking as PC or PT or PSB. That you read the question carefully. An AM transmitter radiates 50 watts with a modulation index of 0.707. With a modulation index of 0.707 means whenever the modulation index is available, mu equal to 0, no modulation. But mu is not equal to 0, then this is the modulation is done. Modulation is done means this is the total power. Now the total power which is equal to 50 watts with a modulation index of 0.707. And he is asking to determine carrier power and sideband power. Now what is efficiency? The efficiency which is nothing but out of total power, how much power is carried by the sidebands. Therefore, this is the power efficiency which is equal to sideband power mu square by 2 plus mu square, which is equal to 0.707 1 by root 2, which means that 1 by 2 plus 1 by 2, which is equal to 1 by 5, which is 0.2, which is 20%. Now from here you can easily identify. Now what is the sideband power here? The sideband power here is 20% of total power, which is equal to 20% of what is the total power? The total power is 50. Therefore, 10 watts is the sideband power. Now, what is the carrier power? The carrier power, which is equal to total power minus sideband power. The total power is already identified, 50. Now the sideband power is 10. Therefore, the carrier power is 40 watts. Right? Now this is the total power and carrier power and sideband power.